Good morning to all. This class we wish to discuss about interclouds. What is intercloud? Intercloud is an interconnected global cloud of clouds, or simply we are telling that the more clouds are combined together, or simply we are telling extension of the internet network of networks. The intercloud is the interconnecting multiple cloud providers infrastructures. The intercloud would simply make sure that the cloud could use resource beyond its reach, because intercloud is having more clouds. Therefore, definitely we will use the single cloud have some limitation, that is we will overcome that, taking advantage of pre-existing contacts with other cloud providers. Then each single cloud does not infinite physical resources or ubiquitous geographic footprint, but intercloud has to do that. A cloud may be saturated to the computational and storage resources of its infrastructure, but intercloud is not saturated because multiple clouds be there. Therefore, it will survive that. It would still be able to satisfy such request for service allocations sent from its clients. A single cloud cannot always fulfill the request, but intercloud will provide that. When two or more clouds have communicate with each other, another intermediate comes into the play and federated the resources of two or more clouds. That intermediary is called cloud broker. The intercloud intermediate is known as cloud broker, or simply we are telling broker. The broker is the entity which introduces the cloud service consumer and the cloud service provider. Therefore, it will act as the intermediator for CSC and CSP. Cloud service consumer and cloud service provider. The next, what are the players be there in the cloud? We are telling three classes be there. First one is cloud service providers and IT administrators, then software developers or vendors, end users or business users. Then next we wish to discuss types of intercloud. We are simply telling that two types of clouds be there. First one is federation clouds, then next one is multi-cloud. What is federation cloud? Federation cloud is intercloud where a set of cloud providers willingly interconnected their cloud infrastructures in order to share the resources among each other. Federation cloud, they are voluntarily or willingnessly they are connecting that resources. Then in these two types of federation clouds be there, peer-to-peer and centralized clouds. Then next we wish to discuss multi-cloud. What is multi-cloud? Multi-cloud is not federation cloud. Therefore, what is that? They are not connected to voluntarily. They are based on some criteria, or sometimes they are using used on some benefits. They are connected together. Then multi-cloud, a client or service uses multi-independent clouds. A multi-cloud environment has no voluntary interconnection and sharing of the cloud resource provider infrastructures. Then next we wish to go through that intercloud resource management. It consists of extended cloud computing services, resource provisioning and platform management, virtual machine creation and management, global exchange of cloud resources. Then, one by one, we wish to discuss. First, extended cloud computing services. Therefore, its name also implies we are extending the services. In this, it consists of 6 layers. First one, cloud application. Next one is cloud software environment. Next one is cloud software infrastructure. Then 2 more also be there. That's what we wish to discuss. Before that, we will deeply go through this. Then this is the cloud application, is the top layer. In this only the users are connected. Then this is the environment providing cloud software environment. Therefore, this is also the actually platform as a service. In this only we are providing that platform. Then next one is cloud software infrastructure. This is in this infrastructure maintaining this. This is further subdivided as data as a service, then communication as a service, infrastructure as a service. Then 3 more also be there. We told that collocation cloud services. The next one is network cloud services, then hardware virtualization cloud services. That collocation cloud service means actually this is the security as a service. Simply we are telling that this service is the location as a service, provides security to all the physical hardware and network resources. Then next, network cloud services, NAS. NAS is used for interconnecting all the hardware components. Then last one is the bottommost layer, then hardware virtualization cloud services. This is related to purely physical hardware. That cloud application layers are shown in the next slide. Actually, in this, at the left hand side, we have shown that layers. Therefore, totally 6 layers be there. That's we are shown. But in the right hand side, we are real example for that. What's the example? Really, we are having some services. That example also we are shown in the right hand side. First, applications we are using VELTECH. Then the clouds software environment, ForceCom or App Engine or the Azure we are using. Then cloud software infrastructure purposes, Amazon, AWS we are using, or Azure we are using. So many examples will be there. You go through that. Then collocation cloud service we are using, I think, NTT communications or trust. Then next, network cloud services, NAS, then AT&T. Then physical hardware processor, VMware or Sun Enterprise we are using. Then next we wish to go through that resource provisioning and platform management. In this, resource provisioning is the process of bringing virtual and physical resources online. The resource provisioning has both hands-on component and a bootstrap components. Therefore, always we are bringing that to ready. The resource provisioning happens when a cloud development is first installed. Then types of cloud provisioning are advanced provisioning, dynamic provisioning, user self-provisioning. Therefore, the first we wish to go through that one by one. Virtual machine creation management. Virtual machines are made possible through virtualization technology. Virtualization uses software as a to simulate virtual hardware that allows multiple VMs to run in a single machine. Then a physical machine is known as a host, while the VMs running on it are called guest. Therefore, I think host is a physical machine, then guest is, then within that what are the VMs be there, that's guest. Then how we are creating that virtual machines. The first virtual machine can be created using the following. First, ISO files, identical storage image of optical media files. I think this is in the repository, or simply the virtualized hardware purposes we are using that. Then next, mounted ISO files on the NFS network file system. Then next we are doing virtual machine templates. Then next, existing virtual machine we are creating, or simply we are cloning that. I think multiple copies of that we are doing. Then last one is virtual machine assemblies. Using these steps we are creating virtual machines. Then distributed VM management steps are: first one, a distributed VM manager makes requests for VMs and queries their status. Then this manager requests VMs from the gateway on behalf of the user application. The manager obtains the list of requested VMs from the gateway. This list contains tuple of public IP or private IP address for each VM with the secure cell SSH secure socket cell tunnels. Then global exchange of cloud resources. Global cloud exchange services a market maker, bring the service providers and users together. Therefore, actually this is the where in market what is happening. Therefore, all products are coming in this, and that user is also coming together. That is the cloud exchange services as a market maker, brings service providers and users together. The University of Melbourne proposed it under the intercloud architecture. It supports brokering and exchanging cloud resources for scaling applications across multiple clouds. It aggregates the infrastructure demands from application brokers and evaluates from against the available supply. Global exchange of cloud supports the trading of cloud services based on competitive economic models such as commodity markets and equations. The global exchange of cloud resources is shown in the next figure. Then this is the diagrammatical representation of that global exchange of cloud resources. Therefore, all resources and uses are come to one place. That is that we are making like that. That is called global exchange of cloud resources. Then next, we wish to discuss the resource provisioning. The resource provisioning are classified into static resource provisioning, constant resource provisioning, demand-driven resource provisioning, event-driven resource provisioning, popularity-driven resource provisioning. Therefore, one by one we wish to discuss. Everything is resource provisioning, but how they are providing that, based on that it will vary. Then static resource provisioning. In this, three cases be there. Three cases of static resource provisioning policies are: first one is case A, over provisioning. Therefore, providing with the peak load, buck load causes heavy resource waste. They actually beyond the range they are providing, that is shown in the diagram, that is the shaded area. This is over provisioning. Therefore, real capacity is less, but we are providing more resources. Then case B, under provisioning of resources. That results in losses by both user and provider. Users have paid for the demand. They are expected more, but we are providing limited. That's why it is called under provisioning. It's not used by users. Then case 3, declining in the user demand results in the post resource waste. Therefore, we are providing, but this is not satisfying the user requests. Then constant resource provisioning, actually fixed capacity to declining user demand would result in the even post resource waste. The user may give up the service by cancelling the demand, resulting in reduced revenue for the provider. Both the user and provider may lose in the resource provisioning without elasticity. Next, demand-driven resource provisioning. The provide static resources and has been used in grid computing. This method adds or removes nodes based on the current utilization level of the allocated resources. When the resource has surpassed a threshold for the certain amount of time, the scheme increases the resource based on the demand. Actually, demand driven means based on the user needs that's provided. When the resource is below a threshold for the certain amount of time, then resources could be decreased accordingly. This method is easily implemented. The scheme does not work out properly if the workload changes occasionally. Next, we have to go through that. This is the diagrammatical representation for demand-driven resource provisioning. Therefore, based on the request that is provided. Sometimes user is ideal, it will limiting that. Then next, we wish to go through that event-driven resource provisioning. This scheme adds or removes machine instances based on the specific time event. The scheme works better for seasonal or predicted events, such as sometimes Christmas in the west and the Lunar New Year in the east. During these events, the number of users grow before the event period and then decreases during the event period. This scheme anticipates peak traffic before it happens. The method results in a minimal loss of quality of service if the event is predicted correctly. Then that event-driven resource provisioning is also solved that. Then Next, we wish to go through that popularly driven resource provisioning. In this, Internet searches for popularity of certain applications and allocates resources by popularity demand based on Internet traffic mentioned. The scheme has a minimal loss of US if the predicted popularity is correct. The resources may be wasted if traffic does not occur as expected. Again, the scheme has a minimal loss of quality of service if the predicted popularity is correct. The resources may be wasted if traffic does not occur as expected. Therefore, popularity is shown in this diagram. Okay, thank you. We will discuss the remaining in the next class.